Not all walls you see in a building are architectural walls. When you are reading an architect plan or structural blueprint, you will understand that all walls are not the same. We have architectural walls, load-bearing walls, and shear walls. In this video, we are going to discuss shear walls in buildings. Let's start by asking the simple question: what is a shear wall? In layman's terms, a shear wall in a building is a structural element that is designed to resist lateral forces acting on a building, such as earthquake and wind load. But this is still not a complete understanding of the meaning of shear walls. First of all, you need to know that all reinforced concrete walls are not shear walls. In order for a reinforced concrete wall to be called a shear wall, it needs to behave and act like a shear wall. This now leads to another question: what is the behavior of a shear wall? How does it behave? There are some quick tips to know a shear wall. If the shear wall, the inertia of the wall is more compared to the overall columns put together, then it will also qualify as a shear wall. You also need to understand that the position of this shear wall also plays a crucial part in becoming effective. Even massive stiff walls or shear walls will not be able to resist the base shear of earthquake load if the shear wall is not properly placed. Let's take a look at the positioning of shear walls. In large projects, the shear wall should be properly positioned. To avoid torsion in the building during ground movements caused by an earthquake, it is important to make sure the center of lateral mass matches the center of stiffness. The position of shear walls will be finalized based on careful analysis. Shear walls must be designed to be placed symmetrically around the building's central axis. What do I mean by this? Let's say, for example, there is a shear wall on the north side of a building. There should also be identical shear walls on the south part of the building. If there is a shear wall in the southwest corner of a building, then an identical shear wall will be placed on the opposite side of the central axis in the southwest corner. Now that we understand this, let's try to answer another question: are shear walls always around lifts? Most structural designers provide shear walls around the lift, since this is where the architect and also the client is okay with having a huge wall. However, if the lift position is at the corner of the building, the shear wall may not really be necessary. This is because it may induce torsion in the building in the initial mode, and this will result in a brittle failure during an earthquake. Shear wall is not dependent on whether there is a lift existing in a building project or not. You may need a shear wall in a building in order to resist lateral forces, even if you don't have a lift. The lift has nothing to do with the need for a shear wall. Shear walls are not designed to resist just earthquake forces. They are also designed to resist wind forces. When your building is slender, or if your building is very tall, say 20 stories, wind forces can be significant, sometimes even more than earthquake forces. So, placing a shear wall in such a building will act as bracing against wind forces. Now we know about shear walls, another question we should ask is: do we also need a shear wall in low-rise buildings? Shear walls may be needed in low-rise buildings based on various factors. It may depend on if your low-rise building of 3 stories is in a seismic zone. It may depend on the number of columns and their position. It may also depend on the size and orientation of the column. If the total lateral design shear is not resisted by the column, regardless of the building being a low rise, a shear wall may be needed. But you also need to take into account the cost, since shear walls can be pretty expensive. There is no guarantee a shear wall will keep a building from collapsing. What we do is seismic resistance design. We are designing only for a part of the actual expected seismic forces. We don't design earthquake-proof structure, we design earthquake-resistant structure. If we try to make a building earthquake-proof, it results in massive sizes for the structural method, size or shape, or even just being around the lift core. No. A shear wall can be considered a shear wall if it is attracting shear due to its stiffness and position. In addition, it is also designed to withstand shearing stresses, which are horizontal forces. The purpose of a shear wall is to resist lateral forces as a vertical